Alright guys, so I just started working on this 20ez and I want to show you something here. Right now I'm just cleaning the board, so not very exciting, not something to record. It's a little time consuming, but I like to do it, make sure everything's good to go. But here's really why I'm cleaning this board. You see this stuff? There is just crud. This is a section I've kind of cleaned up a little bit. As I move over to the left here, you'll see just who knows what this stuff is. I have no idea, but it's really bad. I mean, I've already gone over this kind of once, just spraying it down, but it's just filthy. It's got some sort of, I'm not quite sure what that is, but it's can't be good, and it's all over. And if it's at least a bit conductive or has any sort of capacitance to it, well then that'll cause things to fail. So it's really important to get these things cleaned up before you really do any real testing with them, or heck, if even try, I'd like to clean them up before I even repair them. So anyways, it can get pretty bad. So I want to take some time, I'll get this guy cleaned up, and then once he's all cleaned up, especially on the solder side, then I'll go ahead and get started with removing all of the capacitors on the board so we can get them replaced. Okay, and here's the board after I've given it a good once over. Kind of follow the gleam of the light there, and you can kind of see how much it's actually been cleaned up. So, got the board in the pen device, and I'm ready to get to soldering and, or actually desoldering the capacitors on the board. But first, I need to freshen up all the different soldering points here on the board so I can get them easily desoldered and ready. The board's nice and clean. It's looking really nice, so it should go fairly smoothly. I'm going to get started here. I'm just going to go by my little map here of capacitors on the board. I'll follow this. I've got everything marked, and everything lines up as far as where the capacitors are located. Actually cuts off a little bit here. There's one capacitor here that's not listed on the map. Oh, actually, I'll turn it this way. I had to add it, so I added that there, and this is the orientation of the map in comparison to the board, so I can pretty much just lay it on here right here. And this is where all the capacitors are on the board. So if I lift it, we have the 407 here, we've got 408, which is right here. So I'll follow this map and just freshen up each one of these capacitors, so we're ready to go ahead and desolder. So I'll just start here on the edge and work my way around.
See the whole thing, just forward with it, so you can see where I'm going from the board. I'll be down here. Make a quick adjustment here. Okay, that should be a little bit better. That's almost all out.
So my tip's getting a little bit dirty. So as you, let's see if I can. Come on now. Yes. Ooh. There we go, you can see that. All the black stuff on there from the flux, so I'm going to keep that clean. See a cap here, no polarity cap, 479. I don't see it on the list. I'm wondering why we don't replace that one. Non-polarized caps are 162 and 411. 411 is here. And 162 is up over here, right there. So, not sure. I'll come back and I'll take another look at that guy in a little bit. Flip the board around. So all the capacitors on the board are marked with these little circles. So you can see this little circle, that's a big one right here. So as you're looking through here and finding the C's, the C161, C303, find the circle that's closest to your C410, C411 right there. So that's what I'm doing. I'm finding all the little circles, matching them up on the map, and just adding fresh solder to them. 453, just right here. Also on the back of the board here you can see pluses and minuses. So when you get in these tight areas, you want to be very careful where you're putting your iron and where you're putting your solder, so you don't bridge any connections that aren't supposed to be bridged.
So it becomes somewhat precision work. So just take your time, go slow. Keep your iron clean, and everything will be okay. So I'm kind of working away on the right, moving over, now I'm going back up, and then turn it around. So that's kind of how the capacitors lay out on the board as far as the ones that you're replacing. Which is pretty much all of them. Some C202. That's the capacitor I'm on right now. And then
162. Just going to move up a little bit here. This is one of the no polarity capacitors, and you can see here I've got a bridged right here. I'll make a note of this mental note that this, actually I'll put the note here on the piece of paper, that for 162 he's got, right here, he's got these two connections. He's actually bridged onto this resistor 162. So I want to make note of that connection right there. I'll put it on my piece of paper here, my map, that C162, the no polarity cap, has a bridged connection on, well, it's no polarity, so it's not going to have one side or the other, but I won't say it's it's bridged to the resistor of 162, R162. So when I come to that and put the new capacitor on here, I'll make sure that I maintain this bridged connection. So, got to know that, so I'll continue on with my work.
162 is done, so I'm going to go up to 469. It's right here. Okay, 201, far right. Oop. I need to get this camera so it's kind of more aerial than it is on the table. It's on the table right now, and it's coming away. It really work. Okay, so 459, shift over this way just a little bit. Should be right down here. Okay, and then 468 is north of that. Here. Making kind of a mess, but it's okay. It's all coming off. I'm just adding solder to it. Alright, and 467 is north of this guy. He's just right at the top. I can see him or not. It's way up here. So right here, it's 467. Okay. And I'll move to the left here. Go towards C458. Before I do that, I've got just a little bit of solder left, so I'm going to toss that. Get a new strand here. Throw out my weight, snip it off, and get it down. Okay, so we did 467. Let's go to 458. C458. Should be here.
I don't see the number, but that should be it. It's a little circle C406 is right here. So yeah, this is C458. Kind of hard to find the label on the board, but so it's getting kind of busy right in this area of the board. So I got to be very careful. Oops, a little bit of solder splash. It's got my finger. I've got safety glasses on, so you don't want to wear safety glasses. This stuff, it will splash a little bit, so you got to be careful. 406. Running my iron temperature at 675 right now, degrees Fahrenheit. Okay, so 406 is done. 458 is done, so I need to move up north to 464, which is up here. Okay, and then 472, right up here. Just keeping an eye out, make sure I don't splash anything anywhere and make a mess. Okay, so that should be all of them. 470, I'm going to go back and just double check. I got 471, check. 407, 406, which is right. Oh, that's 408, which is right here. And then 410, 411 is 479. Didn't do that one. Look at that real quick. Hold on one second. Okay, you can see here, this is where that 479 is at. No polarity cap. There's a place for it on the board, but there's nothing there. So I was like, man, am I short a capacitor? No, it's just a placeholder on the board, and there's no need to replace what doesn't exist. So I can safely ignore that area and just move on. Okay, so what I'm going to do is I'm going to go ahead and roll through this board, removing the capacitors. I'm going to get them all removed because I want to clean the board afterwards. So I'm not going to remove a capacitor and then replace it. Got them all mapped out. I've already double checked every capacitor on this board to make sure that it is the proper, make sure I have an equivalent capacitor for replacement. So I've gone through the entire capacitor map and double checked everything. So what I'll do right now is just run through all the ones that I have marked here on my piece of paper and that I have verified on the board, and also freshen up the solder point. So I'll go through each one of those and pull them off the board one by one here. So I'm going to start with one. Start the same direction I started with resoldering the connections, and I'll just work my way around. So here's 471. Okay, so that's out. 407. There's some long leads, so what I'll have to do is just, it's out. I just have to bend the leads a little bit, but I'll keep working my way around. So on to 410. Okay, so it's out. 410. Do 411. It also has some bent leads, but it's out. Should be able to work it out here. It's a pretty small capacitor. There we go. There's 411. On the 161 here. And so this guy's got a nozzle on him, and it's open. And what you can do is you can set it over the lead, and as you achieve full solder melt, you kind of rotate it a little bit, or go back and forth, left to right. And that pulls the lead away from the pad itself so that you make sure it doesn't reattach to the pad once it's desoldered. So you achieve full solder melt after 1 to 2 seconds, and then extract the solder. So this guy's, make sure I'm pulling on the right one here. No, I'm not. There he is. Yeah, I don't want to yank the wrong component out. Okay, so there we go. There he is, 161. Just keep my tip clean here because it definitely gets dirty. Okay, so 161 now to 609 towards the bottom here. This is close to the this is the high voltage area next to the IC 601, which commonly goes out. So this is 609. Okay, 609 is out. 610. Oop. Sometimes when they bend these leads on the pads like this, it's kind of hard to get the nozzle around the part. It's almost impossible sometimes, so you kind of have to just move the part as you desolder. So I can hold it on the back side and just wiggle it as well to help myself out a little bit since I can get the tool around it. Okay, so there he is, 610. So we're just cranking through these guys right now. So I've worked my way down. See if I can pull the 607 out real quick. I won't worry about that. No big deal. Okay, so got 161.
166. Nope, so let's get that down. 166. Okay, 166 is out. On to 303. Let's go right here. Okay, just follow down. 303. 301. Stand by, I'm going to go ahead and check my tool here, so I'm going to kind of suck a little bit. I'm going to do it quickly. A small cleaning tool here. Just run that through. Make sure it goes through. Okay. Got a small jam in here. Just rinse that through and see if we can get that out of there. There we go. Alright, so we were on 301, just partially out of there, let's go ahead and finish that guy out. I have to add a little solder if he doesn't, so during the extraction there, didn't pull everything out, so what I'm going to do is, instead of fighting with it, just come back to that part. Got some more bent leads here, so. Oop, there it goes. You can just fly out there. Okay, so that was out 301. Clean it back up a little bit. Moving on to 453. So it's these mixer guys right here, these three dudes. So I'm going to start with 302 first for this guy. Okay, so 302 is out. Slide on over and hit 453. Okay, 453 is out. Now up to 454, or 454. Okay, should be this area. Okay, now. There we go. 454 is out. Now on to 202. Come to the right over here. Okay, so 202 is out. And the 162. So there's no plate cap, there's a bridge connection. Actually, it's a bridge connection both for 162 and... Let's see, the big one, that resistor. So it's bridged on both ends, so we can make note of that. I made note of R160, but it's also bridged to the resistor about as well, so... Yep, so no plate capacitors been removed. I'll go north of that to 469. That guy falls out easily. And 201. Okay, so 201 is gone. Come back to the left to 459. Find him on the board. I think it's right there. There we go. Up to 467. He's up top here. 467. I feel like I'm moving around with that. But I'm pretty sure I'm not. Trying to move 468. That's silly. I skipped one. Okay, so there's 468. He's now removed. This guy. 467 is north of that guy, so I just need to move up a little here. There he is. It's a little bit of heat on his leg that kind of stuck to the pad, and out he comes. 467. Down to 458. Should be this guy right here. Okay, so 458 is removed. Moving on to 406. Okay, 406 is out. Alright, 464. Moving up top here. Getting clogged again, so. It's a little guy. There we go, 464 is out.
And then finally 472. Work my hand around, see if we can get the last one out here without having to clean. We are clogged. Let me go ahead and clean this. Okay, nice. In just a matter of a couple of seconds, I'm clean and ready to go. Alright, I'm coming way up top here. You can't see what I'm doing. Let me adjust the camera. Going over here to 472, finishing him up. Pulling out the last part here. And 472 is out. That's it. That is all the capacitors removed from the Sanyo 20ez main chassis board. Alright, so let me go ahead and clean this guy up, and we'll get him ready for all of the replacement capacitors. Alright, so stick with me. Okay, so I'm just going to run through a few of these capacitors and see which ones are good and which ones are bad, the ones that I pulled off the board. This is a 100 microfarad 160 volt capacitor. It's currently reading 109, so that seems to be within parameters. We're just doing basic capacitance check on these. I don't have anything better that I can use to really determine whether or not the capacitors are bad. So this is all we got to go off of. Here's another one. Seems to be bouncing around a little bit, but tends to read at 110, so that is within its parameters. Here is this is a 10 microfarad, seems to be reading okay. Here's a 220. Seems to read fine. Here is a 330. Oop. Let's do another 220 here. Looks like another 220. Okay. This one is a 10 microfarad. Making sure to put my black lead, of course, on the stripe into the capacitor. That one seems to read okay. Here is a 330. Looks a little suspect here on the bottom. It's kind of bloated. Seems to be reading within spec, but I mean, kind of look at it, I don't know if that's normal or not. And who knows what these guys will do when they're under load. Alright, here's a 220. Looks pretty good. And these guys are going to have certain tolerances, so they're not going to read their exact rating. Here is a 470. So pretty close. Here's a non-polarity capacitor. It should be read somewhere around 4.7. Close enough. Actually, that was somewhat high, but here's 1 microfarad, so we're reading 1,000 nanofarads, which is pretty much spot on. There's another 1 microfarad, should read around some 1,000 nanofarads, which is good. There's another 4.7. This one is polarized. I'm I'm sorry, this is a 47, not 4.7. 47. So yeah, when you're replacing these guys, make sure you're careful and make sure you grab the 47 and not a 4.7 when you throw it on the board. Gotta watch for that. Okay, here's another one. This is another 1 microfarad. So somewhere around 1,000 is good. 1,000 nanofarads. This one is another 1 microfarad. That one is certainly not reading correctly. It's reading 1 nanofarad. So this guy is done. So we have found certainly one bad capacitor. And this is a 1 microfarad 160 volt capacitor. So this guy was riding and supporting the high voltage area of the board. So that could cause some serious problems. So we know we got one so far. One that is certainly bad. Moving on. This one is a 100 microfarad 16 volt capacitor. Let's see if we can get a reading off this guy. Trying to get a reading. Wow, 2 in a row. Yeah, I can't get a reading off this guy. So looks like he's reading just short. So yeah, no good. This is a 100 microfarad 16 volt capacitor. At the beginning of the video, you'll see that you should have seen the condition of the monitor before we started all this. Oop, phone call. Hang on one, guys. Damned telemarketers. Okay, on to the next one. This is a 22 microfarad 50 volt. That one seems to be close enough. Here is a 4.7, no polarity. Good enough. Here is a 1 microfarad 160 volt. Oh, we had a reading there for a moment. Let's see if we can get that back. So I'm just trying to make sure this has good contact. I think this one might be done. Another 160 volt 1 microfarad capacitor that is giving us nothing. So another bad one. There we go. So far we've gotten 3 bad capacitors out of the lot. And this seems, so far this has kind of been about right for how many are good, how many are bad. Here is a 1 microfarad 50 volts. Alright, get a good reading off that guy. 10 microfarad 25 volt. There we go. So looks good. But again, even though we get readings on these guys, who knows what they do when they're in circuit and under load. From this basic test, we can only assume that they're good, but you'd really have to put them through some more, get some better testing gear. Then this is a great tool for initial tests and to get an idea what might be wrong. But for in-depth testing of capacitors, you need something a little bit more specific for capacitance testing and ESR meters, stuff like that. So anyway, so we've gotten 3 out of the lot here that's bad. So we know we'll at least fix these problems. Alright, so I went in and bagged the capacitors, got my supposedly good capacitors, question mark, in this bag, and then the bad ones in this bag that I know to be bad. I'll go ahead and combine these 2 bags and I'll put them away for later. Should I need to reference them, pull them out again, test them again, potentially slim chance maybe use them again, unlikely, but if for whatever reason I may need something out of this bag, I'll just keep them short term and then dispose of them later as necessary. So here's the main chassis board with all the capacitors removed. As you can see, there's a lot more space to get in here for cleaning with all these caps removed. They're not in the way, so what I want to do now is just kind of go through the board and get things cleaned up a bit Still need to take that guy off. he's still stuck on there, so I'll need to remove that guy. But yeah, so I'll go after the board and I'll clean it off, wash it off real quick, and get it ready for putting the new caps on there. But I'm going to go ahead and get it clean first before I put all the new ones on.
So just blasting the board with electronics cleaner, PCB cleaner, especially just a fine contact cleaner, and just doused it in high percentage acetyl alcohol. So just kind of doing a little final stage, I guess, to clean this guy up. Just a bunch of gunk that's on this guy. Get most of it off.
Can't believe it! I actually missed a cap. Probably screaming at me, saying, "Go back, go back, go back," as I was desoldering all those capacitors. I guess that's why. God, I can't get this thing to focus with it. Darn. Anyways, here we go. This is 408, a 1 microfarad, 160 volt capacitor. Also bad. So that's now 4 capacitors we've got on this board. That's bad. So, anyways, pull them off. So I'll add him to the bag of bad capacitors. So the board's all cleaned up, dried, ready to go. I have all my capacitors more or less organized on my tray here by size or by microfarad, so I'll be able to find them a little bit easier and put them onto the board. I've got my map ready to go, so let's go ahead and move over to the board and get these components back in place. Okay, so the first 2 capacitors I want to put on are these 10 microfarad 160 volt capacitors, and it's going to go in position C471 and C410, I believe, just down here. These are both 10 microfarad 160 volt. So let me get these out of this paper packaging, and then I'll be right back with you. Okay, so I don't remember which ones I said I'm going to go, but it's 471 and 407 that's going to be receiving the 10 microfarad 160 volt capacitors. So I just need to make sure I get the legs right, get the negative side here as depicted on the board. So I just need to route the legs to the holes. See if we can do this backwards or not. Here's 1, 2. Okay, capacitor in place. Looks like it's holding very well, fairly well in that position. So go ahead and grab my soldering iron and get it into place here. Oop. So there's that one. Grab this guy and put him into position 407. So the negative is on this side, so I need to take my negative lead there and make sure he gets in on that end. See if I can navigate. This one's a tough one to get into place. I don't know if I can do this from the opposite end. Yeah, hold on one second, let me put him in place. Okay, got them through the holes. Looking good. Let's move on to the next one. Okay, the next one I want to do is 408, and he's going to be this 1 microfarad 160 volt capacitor. These little turquoise greenish colored guys. So I'll put them into this position here. The negative on this side, positive on that side. So let me go ahead and get this guy through hole mounted. Okay, capacitor 408 is in position. Okay. Let's go to the next guy. Okay, the next one is going to be C410. Calls for a 100 microfarad 160 volt capacitor, one of the largest ones that Bob includes in his kit. So I'll be putting them into this connection here, at this point on the board here, C410, with the negative lead on the bottom side here, positive lead on the top. Get this guy mounted real quick and we'll get him soldered into place. Okay, C410 is in place. I don't know if you can see what I'm doing or not. I'm trying to hold everything so you can see what I'm doing. Okay, that looks good. Let's move on to the next one. Next capacitor is going to be this 4.7 microfarad 50 volt. It's going to be here in this no polarity point on the board, C411. This is a non-polarity cap. Though it does have a short lead and a long lead, it doesn't matter which way you put it on the board, as the capacitor has no designated polarity to it. The next capacitor we'll be doing is C161. Calls for a 16 volt 220 microfarad capacitor, and it's exactly what we have in our parts kit, so we'll get this guy on the board. Okay, here we are at C609, and we'll be mounting a 470 microfarad 16 volt capacitor. The original was a 10 volt capacitor, but since this one is 16 volts, it will work just fine. So this is the guy that's going to be going on the board for C609. Next is going to be C610, which calls for a 1 microfarad, 160 volt capacitor. We're in the high voltage area here with IC601, as well as the gain transformer here, transistor right here. So this is where kind of all the magic first starts to happen. There's that 300 milliamp fuse. It tends to get blown when you lose your hot, but this is the area that we're working in, so we're dealing with higher voltages, so we need higher voltages on our capacitors. Not sure you can see this or not, but after I was doing some inspection of that soldering connection, I noticed that this resistor R607 that's right next to C610 lost a little bit of its solder when I did some solder sucking, so I need to come back in here and reapply some solder to C607. And if I happen to bridge these two, it's okay. They're on the same circuit, the same trace here, so no problems there. Even though I did not bridge that connection, it's okay if I did. So that looks good. He's back into where he needs to be. So I'll move on to the next connection, or the next capacitor. All right, the next capacitor is going to be C166, which calls for a 1 microfarad, 50 volt capacitor. Just what we have in our kit.
Next is C303, which calls for a 10 microfarad, 50 volt capacitor. I'm going to come around here, so I'm not blocking the view. Alright, not too shabby. On to the next guy. The next capacitor is C301, which just so happens to be the same value as the previous one, which is a 10 microfarad 50 volt capacitor. As I do each one of these, I'm trying to make sure that I double check the values, I double check the polarity, both on front and on back. So I'm taking my time as I do each one. I'm not rushing through this at all. I find this somewhat enjoyable, so I don't see a need to really go quickly. Alright, this next section is going to be a trio of 1 microfarad 50 volt capacitors for C454, 453, and C302. So these 3 points here on the board are all the same capacitor. So I'll go ahead and mount these 3 and we'll do all 3 at the same time. I want to look these over real quick because that was really tricky to try to maneuver my hands around that area. So let me take a quick look at all these joints and make sure they're okay. Trying to take a look here to see, make sure everything is sloped correctly. Make sure all those solder mounds look pretty good. So I'll take a closer look here and make sure everything's okay. Okay, so we're moving on to C202. This calls for a 220 microfarad 16 volt capacitor. Let's get this guy mounted. calls for our last non-polarized cap, rated at 4.7 microfarads. This particular non-polarity is 50 volts. Rating is only necessary, I believe, for 25 volts, but 50 volts works just fine. Again, the leads and polarity on this one, since no polarity doesn't matter, so I can mount it either way. But we'll get it in this point here. If you remember, this particular cap was bridged to the resistor, so I need to go ahead and make those bridge connections. There, and up top as well. Go around here. There we go. Let me double check my work, and we'll probably move on to the next one. Alright, we're making our way into the home stretch here. Not too many more to go. We have C459 calling for a 100 microfarad 16 volt capacitor. Just what the doctor ordered. Let's get this guy on the board. Next is the C469, calling for a 220 microfarad, 25 volt capacitor. Let's get this guy on. Moving on to C201, calling for a 10 microfarad, 25 volt. No problem, I've got a 10 microfarad, 50 volt capacitor. No worries. Get this guy going. Man, it's getting a bit dicey here trying to get through all these little leads. Gotta get creative. No problem. Alright, took a quick count. We have 19 down, 6 to go. Moving on to C468. It's going to be a 330 microfarad, 25 volt capacitor. Getting a little bigger. We're moving up. So I'm trying to touch my iron to get some better contact there, and then I come to the other side and hit the pad with the solder. So far it's working pretty good. Alright, let's move on to the next one. Alright, last little turquoise guy here. I like the different colors. It's nice. It's fun. Capacitor 467, 1 microfarad, 160 volts. Right on. Way up here on the top. Can I get it in there? Maybe. I noticed in this little area right here, it's a little gunked up. And down here a little bit, still some residue left, so I think I might clean that up a little bit real quick before we move on, before I forget. So let me go ahead and get that touched up just a bit. Alright, so next I'm looking at doing C406, which is a 10 microfarad, 50 volt capacitor. Next is C458, which is originally a 47 microfarad 10 volt capacitor. We have in our hands a 47 microfarad 25 volt capacitor, so a little bit of an upgrade going this particular location. Next up we have 464, which is going to be a 22 microfarad 50 volt capacitor.
And finally, for 472, a 100 microfarad, 160 volt capacitor. One of the big ones. That looks pretty good. Alright, so let me check over my work and we'll wrap this one up. Okay, so first pass here, all I'm going to do is check the polarity on each capacitor, make sure it's facing the right direction. and then make a mark on the capacitors to indicate that I've checked for the polarity to make sure it's in the right position. So just start at the top here and I'll just work my way around. So I'm trying to make sure I've got this little white stripe. Looking at the white stripe on the board, making sure it lines up with the stripe on the capacitor, and just making my mark to indicate that everything's okay. That's been replaced, so let's put a dot on him. He has no polarity. These guys are kind of hiding in here. Hard to see them. One way down here. Actually, a couple. Looks good. Woohoo! Well, I think that's it. One, two. Oh, there's one here. 2, 3, 4, 5. It's 24. 25. Here we go. Okay, so the polarity looks good. I'm going to go ahead and review just a few capacitors, make sure I get all the right values in the right locations, and go through our last couple of checks. But I think that's just about it. So stay with me, guys. We'll wrap this one up. So one of the issues I may have to address, or one component I may have to adjust once the monitor is back in place, is a horizontal width coil, and there's a ferrite core inside of here that will get stuck over time, or frozen, or kind of locked in place. So what you can do is take one of your TV adjustment tools with one of the hex ends on it here, slide it down into the adjustment coil here, and you're just going to kind of work it back and forth, not really pushing hard one way or the other. Right now it's stuck for sure. So I'm just trying to work it loose. This thing's been sitting around for quite some time, so it does not want to move at all. And you can feel the tool will flex a little bit. And so once you feel it flex a little, just don't go beyond that point. Let it flex and then just kind of work it back the other direction. Eventually it's going to break loose. There we go. There we go. Got a little bit of movement. Now it's moving. See? Just like that. So it's pretty much all the way to the right. So it wanted to break left. So you can see it's moving just a little bit to the left there. So I can now turn it and get adjustment out of it if I need to, once back into the monitor chassis. While it was in the monitor chassis, it would have been very difficult to gauge just where the ferrite core is at and how much pressure I'm putting on it. While I've got it on the bench here, I can take my time and have plenty of patience with it and trying to break it free. So it's broken free now. I have adjustment, so if I need to adjust it, I can. The next issue to address while I've got the chassis board out is the B+ voltage pot. And I don't know if all chassis boards are like this for the 20ez, but this pot has been, I don't know what they put on it, but they basically put some sort of compound on it to lock it in its current position. So I'm going to have to remove this compound from the pot so I can get some adjustment or some play onto this pot. Since I've replaced all the capacitors, you typically have to adjust your B+ voltage to get it at the 108 voltage for nominal operation. And to do that, I have to get some sort of movement from this pot. Right now, there's no way to move this pot without removing this compound. So let me find something. The last time I used an X-Acto knife to kind of break some of this away so I could move this back and forth. I don't know if that's the best thing to use. It seemed a bit brutal. So I'm going to try and find if there's another method to break this stuff loose. I don't know if I can do it with heat or if I have to use some sort of, if I still have to use an edge of some sorts just to chip it away until I can get some play from it. So let me take a look, may do a little bit of research and see what the best options are for removing this gunk on the pot. Okay, so it's the next morning here, and I'm going to try to figure out how I can get the glue / epoxy, whatever the stuff is, off the pot without destroying it. So last time I used an X-Acto knife, and it worked okay. I was fairly careful with just trying to scrape most of this off, but it just felt like it was, I don't know, a bit too destructive to the pot. Kind of bent up this metal piece just a little bit, especially when I was trying to work the pot back and forth after scraping some of it off. So I'm going to try to add a heat gun to the mix here and see if I can't soften it a little bit, maybe get it to peel. So that's what I'm going to go for. I haven't tried anything yet, so hopefully this works. Yep, I think this will do it. Oh yeah, this is working. So before, when I try this, it's hard and crusty. But this seems to be loosening it up. Oh, there it goes, look at that. For sure, look, yeah. So here I can just kind of, it's just peeling up. Woohoo! I'll come off for a second. Trying to get some of this out of the way. The bigger problem is that they get it underneath the adjustment point here. The spinning disc. It's on top. So let me grab one of my tools. I want to see if I can't turn it while it's still kind of pliable. Gotta find the right size here. This work. So it's like dead centered, so I'll remember that. The pot is right in the middle. Let's try this guy. Man, they're all just a little bit too big. Here we go. This should work. Oh yeah. and it turns just fine. Woohoo! Alright, so what I'll probably do is come back, apply a little more heat. Work that loose. Oh, I'll melt my tool. I should probably get a real screwdriver. Uh-oh, hold on. Okay, so I got this little precision screwdriver, Chinese piece of junk. But yeah, it's very free now. Moves easily, it's not choppy in movement, it's nice and smooth. I just need to blow it out just a little bit. Still a little bit of residue in there. So yeah, that worked great. So just a little bit of heat, directed heat, and it will soften up whatever that stuff was. But yeah, the play is very smooth now, much better than my other board that I just went at it with an X-Acto knife. This is much better. So works great now. So we have both the B+ adjustment pot is now adjustable, as well as the horizontal width coil, the core, the ferrite core in the middle is also adjustable. So we now have full adjustment on the board for whatever it is we may need to adjust. So yeah, I think I need to look over a few more things on the board and make sure everything is good, and we may be ready to put this thing back on the chassis. But before I do that, I want to make sure I've gone over everything, because it's a pain in the butt to take it in and out. So I don't want to have to do that over and over again. So alright, stick with me. Let me do a few more checks on the board and see what we have to do next. Okay, so something to note, which I kind of exciting for myself, but so when testing pots, these variable resistors, you can set your multimeter to ohms and set the negative. I believe this is correct. I'm double checking myself, but set the negative on the back leg, and then these two other legs here are what you're not able to see that, where the resistance varies. So essentially, when you turn the pot, it's gonna, oh well, you can see it. You can increase resistance on either one side or the other, and the opposite occurs when you turn it. So just for example, if I set my positive lead on this leg, oh man, can't see anything. Over here, you'll see a reading of 3.2, and that's kilo ohms, so that's 3,000 ohms. As I turn it to the right, it's increasing, right? And so if I put my lead on the opposite end, I should get a reading of the opposite. So this is a 5K pot, so 5,000 ohms. So here I'm getting 1.4, approximately 1.45, and on this other side I'm getting 4.7. So if you add those up, you're supposed to get roughly the value of the pot. So if I come back to this other leg here on the opposite side and start turning it the other direction to the left here, I can see what I'm doing without breaking the pot. Okay. Oh my gosh. Okay, there we go. So if I start turning it the other direction to the left, it should start increasing as it does. Nice and slowly, I don't want to break anything. So here we're back to 3,000. So I'm on the left leg, and now if I move more. Continue to increase over 3K towards 4K. And now I'm about 4.5K. So on the opposite leg, we should get kind of what we had before, which is about 1.6, 1.5, something like that. Pretty close, 1.9. So you can see it's changing the resistance values on these two legs. And that's how you get the adjustment value between voltages. And so the value in between of these two values is what is going to be, I think, is what is output on the bottom leg here. So you're changing the voltage level that'll come out through the pot when you make that adjustment. So this pot is in circuit, and this is how it's testing. So my other pot on my Sanyo 20ez chassis board that is stuck at 90 volts does not measure this way. It measures between 0 and 5K on this leg, but on this leg it's measuring like 11K to 16K. So knowing that and knowing the measurements I'm getting from this pot, I would think that this is the correct measurements and the other pot is providing me incorrect measurements. So perhaps a bad pot on the other chassis board, maybe the one that's stuck at 90 volts. So that's a possibility. Or there could be something else that's within the circuit that's causing an issue. If I were to take this pot out of circuit, I would expect to get similar readings that I'm getting now with this pot, which I hope it's still in circuit. It didn't. I mean, it is. I mean, it's still soldered in place. Let me turn it around here. Yeah, I mean, I'm looking at it here. It looks fine. Yeah, I mean, it doesn't look like it's. I mean, there's no broken traces or anything like that. Get underneath the magnifying lens. So I would say, yeah, it looks fine. So these are the measurements I would hope to see on the other pot, on the chassis board that's not working. So VR601 here is where to be located, which is right here. So that's the pot, that's the back leg and the two front legs that I was measuring. And so you can see the resistor sign there and the arrow pointing into the resistor. So as you adjust these two, the voltage that comes out of here is going to be your adjustment voltage, I believe. I think that's how it works. I'm not an electrical engineer. When I'm working on this stuff, I wish I were, but I'm a network engineer. I push packets. So, right. So yeah, I think I could have an issue on my pot on the other board. This one seems to be measuring correctly, the other one does not. So I would be excited to see how this one actually operates when I throw it back onto the chassis and power things up. But first I need to go ahead and clip all these legs. I need to clip all the legs on the board. I just cleaned it up a little bit more. But let me clip these legs, see if there's anything else I need to do. So far we're looking pretty good. Everything's checking out, and I'm ready to get this thing back into the game and test it out. So I've been clipping the leads off of the capacitors and just checking out each area of the board as I come across it. And here's another area of the board that has this kind of darkened area, but I also noticed that these solder points are kind of weird looking. I don't know, they've got some stuff around them. Looks kind of like rust. I'm not really sure what this is. So what I'm going to do is I'm going to clean this up, and I may just go ahead and resolder these connections just to make sure they're okay. So I'll go ahead and get this all cleaned up, and then readdress these solder joints.
Alright, so I'm fairly satisfied with the board. I'm going to go ahead and toss it onto the chassis here, cable everything up, and do some initial tests. here, wiring harness pull all the way through. Once that's all in, you just have to keep checking this neck board here, make sure you don't get it all screwed up. Just cut the board with that. Tuck the board into this little corner. Alright, and then start setting it onto the posts. And I'll wrap the neck board back through where it's supposed to go. Just like that. Get it connected. There. Alright, just rock them in place. It's easy. Okay, so that's in place. So go ahead and tuck these cables into their respective restraints. Start doing all the... That's good. So let's go ahead and make sure the board is down to the posts so it's secure and has support. Just press the board down. Excellent. Okay, so the board is secure and in place, so it's got support. So I can go ahead and start attaching all the connectors onto the chassis board. Snug. So far, so good. So that cable goes back to the inverter board should I choose to use it. Alright. Try to route all these supplemental boards and get them in place. The pot board here, I'll get right down there. There we go, very nice. Bag of screws. Let me find the screws real quick. Alright, got my bag of screws, so I can start attaching things. So right now I just screwed down the ground. I'll attach the anode cap in a second. Let's go ahead and get the audio board in place. You can see that. Sitting right here. A nice clean audio board. I got screws here for moving around. All these connectors in place are all labeled. This is JB inner key, so it's hard to go wrong. Now I'm just going to tuck the power cord in the restraints for the time being until I get everything tested out. It's JB, JD, JC. Those are all in place. Just the gauze goes into AD on the chassis board. So those are all connected. Piece of cake, right? So we got left the audio, power, and then I'm not going to attach the inverter board right now. I'm just going to grab the video cable and just route it through here. Attach it directly to the chassis board. And then for my initial test, I'm just going to bypass the inverter board. I'll tuck it right into here and just let it hang loose for a moment. So there's our 3 connections, video connections in place. Let me move the camera around here and I'll get the anode cap attached. Okay, hold on a second.
One thing I'm going to point out, I did a little bit of, I used a wire brush down here on the ground connection, both on this metal piece here as well as this cable and its termination point. And so I made sure this was nice and clean so we had a good ground connection from the board. I want to make sure that everything is well grounded, that needs to be well grounded. So just pointing that out. So here's the anode cup. I'm going to just pull it back like that and just hook the little ends in there. we go. Somebody needs some help. Hang on a minute, guys. Okay, got just about everything connected here. The last thing I have is this shield. I'm going to put the shield on so I can protect the neck board. Good. It's kind of rough, but it's in there. So you can grab the 2 screws for that. Don't lose them because these screws are just a little bit different than the rest of them. Okay, so that's in place. Don't think there's anything else. Double checking everything. Nothing's been changed on the flyback. All those connections are still good and in place. Got my ground. Got my video connection. Everything looks good on the hot. The gauze is connected. Audio board is connected. Hot board is connected to the audio board. Yeah, I think that's it. Let me go ahead and get this guy back into the cabinet, and actually I'm going to set it onto my stool here, and we'll just get it plugged in. Hang on a second. Okay, so it's the moment of truth time. Oh, I forgot a connection. Woohoo! Thought I saw that. The power cable isn't plugged in yet. This is the ground connection for the neck board. Okay. Okay, so you can see my multimeter down there. I believe you can see the reading on that. So that's all connected to the test post for the B+ voltage. I've got everything connected. I've got it connected to ground. I've got the monitor grounded 2 different ways to the chassis, which leads back to ground, earth ground. Everything is connected on the board. I've got 2 different TV adjustment tools in place. I've got one on the horizontal width coil and the other one on the B+ adjustment pot. So I'll be able to just reach to the tool. The tool's already sitting in place and it's ready to be turned and adjusted, whatever necessary. So let me go ahead and I think I need this light. Do I? A little bit better, so you can see the screen a little better. Okay, let me go ahead and turn this on and let's see what we get. Plug it in. Our cable's connected. Hopefully we don't get a loud pop or anything like that. Alright, here we go. Okay, so far so good. Hey, this is great. So right now we've already got B+ voltage. We're sitting at 106.8. So that's good. I can hear the high voltage. You can hear the snap, crackle, and pop. We're up to 107 right now. Still no image on the monitor. I'm looking for anything like sparks, smoke, that kind of stuff. Okay, so far nothing on the screen. Still waiting. Gonna give it some time. Still nothing. Let me see if I can't maybe turn the flyback up a little bit here. I'm not going to touch anything. Just grab my adjustment tool. I believe this is screen right here. I think it may be turned all the way down. Let me turn it up just a little bit. Okay, we have something. That's not good though. Turn it a little bit more. Okay, so yeah. Well, the good part is that it's filled. Bad part is it looks really bad. So the whole screen is filled, top to bottom, left to right, so that's good. This is a new one on me. Let me see if I can adjust some of the hold pots and see if we can't get a clearer picture. I don't know if this may be a Alright, so turn a little bit. Nope, that didn't help. Okay, and we know the game is good. We just got some sort of an issue here. See if I can figure out what I can adjust. Let me check the pots on the neck board because I'm not sure what order they're in. See if we can't get something better. Hold on a second. Okay, I'm pretty sure this has something to do with my vertical sync signal or something. But let me go ahead and adjust this B+ voltage while it's running, and I want to try to figure out the vertical sync issue. Okay, so there's 108.1. I think that's a good point for it. So I'm going to leave it right there, and let me go back and seems like it changed a little bit as far as what's going on the monitor here when I modified that, so I guess that could be good or bad. Looks about the same. Yeah, let me figure out what's going on here. I think I've got an idea, but let me do a little bit more research and I'll probably nail this one here in just a moment. Stay with me, guys. Ah, got it. It was the horizontal sync H-hold on the chassis board was totally off. So there it is. I will here adjust it real quick so you can see what it does. I couldn't find the stupid pot. I was about to adjust the brightness pot, and this one's right next to the flyback and the anode and stuff like that, so be really careful when adjusting this bastard. So let me try to get in here without getting close to anything. I'm not touching anything else. Okay, so I'm on it, so when you move it out of alignment, that's what it looks like. When you bring it back in, so there you go, it's getting close, getting closer, and that's what it does when you kind of tweak it some more. So let's get it towards the center there. So that should be a good spot for it. Okay, so there you go. The monitor is back to life. The colors aren't very good though. I don't know if this could be a purity issue or something else. See if I can turn that off. Hold on, let me get you centered up so you can look at it head on. Okay, so here's the monitor. It still needs that. It's got some color issues up here at top. It's kind of, it should be kind of red. This gets kind of orangey right there. Overall, the colors are okay. Let me try adjusting some of the things like brightness and such. So turn this up a little bit. Looks good. B+ is still holding well. It's at 108.2 right now, so that looks good after turning up the flyback. Let's look for anything like jitter or waviness. I don't have any waviness. So the filter cap is holding up okay. I did not change out the filter cap. It's the one that was on the board. So all the colors in here are pretty good. It's just right up here in the center. It looks like it's a little off. Definitely too wide. So let's change our vertical size a bit. Now they have flashlights. Where did that go? Huh. I'm losing all my tools. Hold on one second. Okay, I got my flashlight, got my adjustment tools. Let's fix a little bit of this. So vertical size is a little off. So let me adjust that real quick. I can just probably reach down and adjusted. Here we go. It's pretty good. So it's not going outside the screen anymore. So that looks right. I'm gonna watch the speed plus, see if it changes at all. 108.2, that should be okay. Let me turn off the light so there's no glare. Okay, there we go, so that should be looking pretty good. Looks kind of a little washed out on the camera, but the colors are quite bright. Let's see if I can't. There we go. That might help a little bit. It's still quite bright. Yeah, it looks a lot better than it does through the camera. Let's see here. What else? I don't know. Overall, it looks really good. It does look like it's shaking or jittering just a little. Yeah, it is just a hair. It's really hard to see. But man, talking about what it looked like before, where it was just like white lines, and yeah, this is a lot better. So let me do a little more adjustment here. Make sure it's in focus. Crisping it up just a little bit more. It's looking better and better, so now it's in focus. I guess we could check to see if the audio board works. I don't know if I can reach the service switch or not. I don't even know if I have it plugged up properly yet. Did it coin? It did coin. Oh, I didn't connect the audio at all, did I? No. I wanted to hear if it made any sounds. Didn't even connect the audio. Audio here. Now this thing is smoking though, and it's running really well. There we go. What's interesting though is I don't have any hum or anything coming out of the speaker. It's very, very quiet. Oh yeah, I do. I have to go all the way around to here. It is fairly quiet though. There's no really loud buzz or anything. Let me hook up the control panel real quick and just hit the start button or something. Make sure it plays sound, and I'll adjust the sound level. I should probably turn it down a little bit before I hit anything. Turn it down. Volume right there. Okay, it is down. Okay, so yeah, it's working. Okay, good. Looks good. And just that size again a little bit more because it looks like it's gotten out of whack a bit. There we go. So it sounds okay. Okay. I'm going to have to look up to see what may be causing the jitters. Trying to see if it's still doing it, but I don't. Man, you kind of have to just stare at it. See if it happens. From a distance, you don't really notice. I'll have to look in the video, see if it actually shows up in the video or not, but overall, I'd say this is pretty much a success. So let me go ahead and wrap this one up. If I have some more content to add to it, I will. But yeah, let me do a little more research on the jitter issue. I'll probably come back and address that. But other than that, I'm going to wrap this guy up. It's looking pretty good. So anyways, thanks for watching. Hope you enjoyed.